Let's write an exponential function rule from a table. So let's say that here's the table that we've been given. We have our x and y values. The x values we have are 0, 1, 2, 3, r, and s. And the y values we have are 1, 2, 4, t, u, v. So we need to finish out the table and then write the function rule. So let's start looking for patterns. In our x row, we have from 0 to 1. We can get there by adding 1. From 1 to 2, we do the same thing, add 1. 2 plus 1 is 3. So we found our pattern in our x values. We're just adding 1 every time. So 3 plus 1 is 4, so our r value would be 4. 4 plus 1 is 5, so the s value is 5. Let's look for patterns in our y values as well. 1 to 2, it's adding 1, but here's something that I know. I'm dealing with an exponential curve, right? This whole y equals b to the x plus c thing. And exponential curve patterns for the y values are multiplication, not addition. So this is not going to be the right pattern. So how can I go from 1 to 2 using multiplication? Well, I would just multiply by 2, right? And if I did that again, 2 times 2 is 4, so that works. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, don't know where I was putting that, sorry. 16 times 2 is 32. Okay, so we've finished out our table. Now we need to write our function rule. Pardon me. So, to write a function rule, there's 3 basic steps. First step, in y equals b to the x plus c, let x equal 1. Sorry, first one, let x equal 0. Second step, in that same equation, y equals b to the x plus c, let x equal 1. And the third step, we're going to plug in values for b and c. All right, so let's go ahead and take this information and get to work. Okay. Since I'm going to have to slide this information up a little bit and kind of condense it down, I'm going to look up a few things right now. Tells me in step number 1 to let x equal 0. So if I go up here to our table and see what happens when x is 0, I see that y is 1. So I'm going to write that ordered pair right here. When x is 0, y is 1. Then I'm also told in the next step to let x equal 1. So if we go back up here and see what happens when x is 1, I see that y is 2. So I'll write that ordered pair right here. Okay, so let's go ahead and move this over so we've got the space that we need. And here we go. Step number 1, let x equal 0. So I have y equals b to the x plus c. And when x is 0, y is 1. So the y value is 1, the x value is 0. So we have 1 equals b to the 0 plus c. Anything to the 0 power is 1. So we have 1 equals 1 plus c. Let's go ahead and get c by itself. We get 0 equals c. Okay, step number 2 says to let x equal 1. So I have the same thing, y equals b to the x plus c. And on this one it says when x is 1, y is 2. So we'll plug in 2 for y, plug in 1 for x, bring in the equals b. But here's something. We also know that c is 0. So let's go ahead and plug in 0 for c. So that gives us 2 equals, b to the first is just b, and adding 0 doesn't change anything. So now we have our b value. And the third step says to plug in b and c. So we have y equals b to the x plus c. So we'll plug in the b value we found, which is 2. And we'll plug in the c value we found, which is 0. So we have y equals b to the x plus c. Reduce that down, y equals 2 to the x. So y equals 2 to the x is the function rule that explains the table that we started with.